Good morning, good afternoon, good evening, my viewers, especially the mathematics lovers, wherever you're watching from. In this video, I want to introduce you to what is called Crammer's rule. Some call it Crammer's rule. I don't know the actual pronunciation, but I just know that Crammer is somebody's name. So, Crammer's rule. Please pardon me if I didn't get it correct spelling. What is Crammer's rule? Well, there's a caveat here. Crammer's rule is not for children. It's not for kids. I've been getting a lot of complaints from people who are doing higher mathematics why all my mathematics tutorials are usually for kids and the rest. But I kept on assuring them to wait. I just wanted to develop the topics from the elementary level and gradually we'll go to higher level. But anyway, let me just give them something to whet their appetite. So let's start with an introduction to solving system of linear equations using Crammer's rule. I will say system of linear equations. In one of my earlier videos, I talked briefly about an introduction to a simple linear equation. Now you can have two equations. When you have two linear equations, it becomes a simultaneous equation rather. You can have multiple equations. And why is that so? Yes, in real life, simple linear equations are hardly sufficient to describe a real life scenario. We live in a three-dimensional world and it's actually pretty difficult to describe what happens in our environment to model real world just following simple linear equations. That's why you need a system of linear equations in some cases. So talking about Crammer's rule, I want us to use this very simple example to describe what the Crammer's rule formula can do for us. We'll first of all solve this example using the ordinary methods of simultaneous equation that we know, and then we'll go ahead to use Crammer's rule to solve this same problem and see if we'll get the same answer. So like I mentioned, we'll first of all solve this simultaneous equation, and in doing that, what do? There are various methods of solving simultaneous equation. You see that I'm seeing a plus 2y and a minus 2y here. So what immediately comes to my mind is that if I call this equation 1 and call this equation 2, if I add equation 1 and equation 2, I will have eliminated one of the variables. The variables here are x and y. So I want to eliminate one of the variables so that we'll be left with just one variable. So we'll say equation 1 plus equation 2. What does that give to us? So if I say equation 1 plus equation 2, 2x plus 6x gives us 8x, and plus 2y and minus 2y just gives us 0. 10 plus 6 gives us 16. We have now reduced this to a simple linear equation where 8x equals 16. And all we do here is to divide both sides by 8. X will now be equals 16 over 8, which is 2. We've gotten x. The next thing we want to do is to substitute. So we'll substitute x equals 2 into one of the original equations. So let's take equation 1 again. Where we see x, we will put 2. So 2 into 2 plus 2y equals 10. 2 times 2 is 4 plus 2y equals 10. We'll move the 4 to the other side. 2y is equals 10 minus 4. So 2y will be equals 10 minus 4 is 6, and that gives us y equals 3. All right, I'm not working all the steps as I used to do in the mathematics for the kids. Just bear with me. So we've got our x equals 2 and y equals 3. Now let's use Crammer's rule to see if we'll get the same result. So to start with Crammer's rule, we want to state our two original equations again. Crammer's rule states that a1x plus b1y equals c1, a2x plus b2y equals c2, where a1, a2 are the coefficients of the x in the original equations, b1, b2 are the coefficients of y in the original equations. Now we can rearrange this into a matrix form. Just watch and see how we do it. A1, A2, B1, B2 times X and Y equals C1, C2. Yeah, if you multiply this matrix out, you will get the same set of equations. Just take note. Now I want to use our original equation to fix in the values into this matrix that we have. So A1 is 2, A2 is 6, B1 is 2, and B2 is minus 2. Our variables remain x and y. Our C1 is 10 and our C2 is 6. So in solving Crammer's rule, the first thing you want to do is the determinant of overall equation. Let's call this equation alpha. So the determinant of the overall equation, and the determinant of the overall equation is simply, you take this a part of the equation, and how do you work out that determinant? It's very easy. You just cross multiply. So the determinant is just 2 times minus 2, then minus 6 times 2. You cross multiply, or you multiply diagonally like this. All right, so that gives you 2 times minus 2 is minus 4 minus 12, and minus 4 minus 12 is minus 16. So let's just call it det A. Det A is minus 16. Having done that, the next thing is what we call the change in each of the variables. The change in each of the variables. And we say, okay, change in x. What do we do when we want to say change in x? Carry the values of the constant terms and put them in the column where we have the x. So watch as we're going to do it. The change in x equals, instead of 2 and 6, we will now have 10 and 6. While this, the coefficients of the b remain the same, 2 minus 2. And we use the same method to solve by cross multiplying diagonally. That's 10 times minus 2 minus 6 times 2. 10 times minus 2 is minus 20, minus 6 times 2 is 12. So that's minus 20 minus 12 will give us minus 32, I guess. So change in x equals minus 32. Please take notes. The next thing we want to do is to take change in y. Change in y. And how do we do that? Again, we carry the column of the constants and then come and put it in where you have the coefficients of b. Constant term, we carry that column and come and use it to replace where you have the b constants. This was our original equation alpha. So 2 and 6, the coefficients of x remain the same, but instead of 2 minus 2, we now have 10 and 6. To look for that change, that simply is 2 times 6 minus 6 times 10. So that 2 times 6 is 12 minus 6 times 10 minus 60. So 12 minus 60 is minus 48. So change in y equals minus 48. We've gotten some key values that we need. That change in y equals minus 48. Change in x equals minus 32. And determinant of a equals minus 16. So let's repeat those key values that we got. And change in y equals minus 48. Now, Crammer's rule states that to get the value of x, or where we're driving at, to get the value of x and y, that x is equals change in x all over the determinant of a. So that gives you change in x minus 32 all over minus 16. The minus will go with the minus. Minus will go with the minus, and 32 over 16 equals 2. 32 divided by 16 is 2. Then the value of y is equals change in y all over that determinant of a. Change in y is minus 48 all over the determinant, again, is minus 16. Again, the minus will go with the minus. So what's 48 divided by 16? I guess that's 3. I guess that's 3. So we've gotten our values. That x equals 2 and y equals 3. The next question is, was that the answer, the same answer we got when we solved using simultaneous equation? Let's go back to the first answer that we got and compare. Oh yes, that was right. When we use simple simultaneous equation, our x was 2, and what was our y? And our y was 3. So we got the same answers. But the thing about Crammer's rule is that you can always extend it. Instead of a system of 2 equations, you can have a system of 3 equations where you have a 3 by 3 matrix, or you have a system of 4 equations where you have a 4 by 4 matrix. Subsequent videos, I'll talk about how we can solve a system of 3 equations, getting the values of the variables where you have a 3 by 3 matrix. Thank you and bye for now. Please, if you like my content, kindly comment on this video, share this video, and follow my page. I am Dr. UAE. Thank you.